So this is Math 1127, Introduction to Stat, and this session or this lesson is about confidence interval. Let's just say confidence interval. Now, there are many different types of confidence interval. So I will focus this session on what we call confidence interval for population means. And what is this? So what is a confidence interval? Confidence interval is is a method to estimate the population parameter. So what are population parameters? Population mean, right? Variance, standard deviation. Sometimes it's proportion. Using sample statistics by so using sample statistic or raw data. And I'll explain what it is by providing a range of values paired with a confidence uh, level or probability of success of so you're like, well, what are we talking about? So basically, if you have a sample data, so whatever data you have, so let's say I tell you the sample means, let's say I tell you the example. Let's say that the means, sample means, let's just say it's 15, and the sample size is 200. And I also tell you that the sample standard deviation is 2. Let's just make it easy. My question would be, with a 95% confidence level, provide a confidence interval for the population mean. So what am I saying? Well, remember I said this before. A sample is basically what you go and survey. So let's say you go survey, in this case, 200 people. You go to 200 people and ask, maybe they're all school age students, right? You go ask 200 of them and ask them how old they are. And you got the average to be 15, and you have the standard deviation to be 2. Now, this is only true, the mean and the standard deviation is only true for a sample, right? For those 200 people, right? You might have 200,000 people. You might have 2 million people from the population, from the entire pool of people. You just happen to survey 200 people. So the question is, can we get a better idea? So we're about to type it up. Basically, we are trying to get a better idea on what the true population mean would have been, would be. But you know that it's hard to pinpoint. It is hard to pinpoint a particular value. So we will provide a range of value or an interval. That's an interval is like, for example, from 10 to 20, from 5 to 20. That's an interval, right? So I'm going to use a calculator for that. I mean, we can do it by hand. In the lecture, in the PowerPoints, there are the formulas. But again, we are trying to do this by applying to real life example. In real life, you're not going to be using it by hand. You're going to be, you honestly might not even be using calculator. You'll be using Excel and stuff. But this is a start. So go to the calculator, the first question is where they're located, right? These confidence interval. You have to hit stat. So on TI 8384, press stat right here, and then press the right arrow button like this, and then you want to press it twice. So let me write it twice, and then to get to test, to get to test. Now for the remainder of this class, you're gonna be using test for pretty much everything. Now scroll down. You see some intervals here, right? So there's two right here, right? Basically, these two and this one down here are the ones we're gonna be using most likely. So you will see Z interval is basically what we call Z confidence interval. You use this guy, you use this if you if the data set the data or the sample size is larger than or is how about at least 30, and you know the population variance or standard deviation. Maybe I should just say standard deviation. Population standard deviation. So you can only use Z. This is Z using the normal distribution as your model. Using Z, this confidence interval, if you have sample sizes at least 30 or more, and you know the population standard deviation. Basically, this is the first session. Right? So use this on problems from the first session of the chapter. The next one is T interval. Right? T confidence interval. Use this if the sample size, if either sample size is less than 30, or you don't know the population standard deviation. Use this on problems from the second session of the chapter. That's T interval. And the one underneath is one prop, Z interval. This is what we call one sample proportion Z interval, confidence interval. Here's a mouthful on this one. Basically, this is to test for not the mean, not the average, but test for the proportion. I'll explain. Use this on problems from the third session of the chapter. And you might ask about the fourth session, right? There's a fourth session. The fourth session is asking for standard deviation or the variance. And it's called a chi-square test, which is this one right here, this chi-square test. But here's the thing, my recommendation is don't use this one because not everybody's calculator has this thing, and it's typically a little harder. So I'm going to show you how to use it on the website as well. So, and I'll show you these guys how to use a web-based calculator. So now, for this problem, right? So for this example we have, for this example, we will use Z interval because the sample size is larger, right? Is less 30, right? It's 200, right? It's 200, which is bigger than 30. And or actually, I should tell you that's the population standard deviation, right? But population standard deviation, and we know, right? So, and we know the population standard deviation is 2. So basically, use this guy right here, Z interval. I click on that, and then it gives you this information. Now, here's the deal. If you are given sam sample statistics, what are sample statistics? These guys right here. So, i.e., sample mean, sample size, that sort of thing. If they give you that, just the sample size and the mean. So think about it, right? This is like akin to if somebody already done the survey and they come to you and say, okay, I asked 200 people and the average is 15, right? Instead of you gotta go do the survey and you found 200 information that you gotta plug in, right? So let's say this is what you're given, and you'll see that two type of problems. If you're given sample statistic, where they give you the sample means and all that good stuff, then use stats on them, or flat stats on input. So that first row, just use stat, you enter it. The data will use it for another type of problem. Of course, the mu, right? This guy right here is the population standard deviation. Let me just kind of remind you, but let me get a sample here. Right, this. Oh, the heck! They make it into uppercase. This guy is the input population standard deviation here. So that will be clear this, and I'm gonna put 2. Okay. So what is the next one? The next one is the bar. Let me see if I can find that here. Is bar x. What is bar x? Bar x is a sample mean. Let me see what bar is, right? Bar x is the input sample mean here. So this is sample mean, and it's 15. And of course it's a sample size, right? That's easy. Sample size. So sample size in our case would be 200. And then what's a C level? C level is the confidence level. This is something that people have to give you. Okay, like in our case, we said 95%. So if it's 95%, you have to put 0.95, right? So make sure you convert the percentage to a decimal number. So calculate. Nice. So here's what it says. It says the confidence interval, and sometimes we say CI, or population mean, is 14.728, 15.277. So you're like, what does that mean, right? So here's what it means in words. It means that if we repeat, we sample this population, okay? If let's say you go and ask another 200 people, the 100 times, if we sample 100 times, right? Let's say we do 100 times, then 95% of those 100 times, or 100 times, will yield a sample mean between 14.723 and 15.277. So that's right. The confidence interval with 95% confidence. So basically, what I'm saying is this: you are not necessarily predicting the actual population mean to the exact. You are just saying that based on information we have, and we go and we examine this population, we go survey one more time, we sample 100 more times, then 95 times out of 100, we'll give you a sample mean between those two numbers. That's kind of like what we call margin of error. Right? We can actually find that was a margin error. The margin of error is, so you can actually use a calculator for this. It's 15. The sample mean in this case is 15, right? So you can do like this: 15 minus 14.723, 0.277. And if you do 15 adding this number, don't you get this number right? 15.277. What does that mean? Margin of error, just how far it deviates, how far is that range that you have, that confidence in a confidence interval you have, deviate from the mean, from the sample mean that you have. So you're like, yeah, between 14.7 to 15.3 or something. That's where the sample mean will lie if we repeat this experiment 100 times, 95 times out of 100. So that is the idea of confidence interval. It gives you an idea on how much elbow room do you have. Now, this is different than what we call, if you want to calculate just the prediction for the population mean, you realize it's more difficult, right, to calculate not the resampled average, but the actual population average. If you want to do that, that's what we call the prediction interval. Now, the PI, that's what I call it. PI is not included in this class, but it's almost the same idea. It's a little bit more difficult, but PI provides you with a more accurate result, but for different purposes. But for this class, all we're gonna do is confidence interval. And honestly, that's most of what people use it for. Even when you do when we had the COVID-19 pandemic, if you actually listen to the press conference, they use confidence interval all the time. Why? Because they want to talk about spread. They want to talk about how difficult it is, right? As far as the information that we have based on the spreading of the virus and how many days does it take before you're clear. That's all, and that's how you come up with 14 days. So on to the first example that I have prepared here. So a marketing research company decides to know the mean consumption of meat per week among males over age 26. Understand that 26 has nothing to do with our particular inputs. It's just people over the age of 26. It's not the mean, not the standardization, nothing. A sample of 952. So the sample size, right, which is n, right, equals 952. So that's the first thing I know, right? We're drawn, and the meat consumption, the mean meat consumption was 3.8 pounds. So the sample mean, right, is gonna be, and I'm gonna be real careful and go ahead and put in the way that your calculator has it, which is this, right, with the x, right, equals 3.9, like that. So we got that. Then the sample, the population, population standard deviation. Actually, go to just make it a little bit. I'm gonna go with spacing. So, the population standard deviation, which is this symbol right here. I use a symbol so that you can, pair that with the calculator. It's 1.5. That's what it says right here. And they want you to construct a 90% confidence interval. So the C level, right? The C level is 0.90. So once you have all the information, this is easy. Right? You can just put into the calculator. Of course, you know because this is still the first session, so then we know you're using Z confidence interval. But how do we know that in general? We'll use Z confidence interval because our sample size is larger than 30, and we know the population standard deviation. It'll be like this for the entire first session, by the way. So let's go to the problem here. So first you go to stat, right? Go to test, and if you go down to Z interval, that's number 7, right? Again, we're gonna use stat, so we're not gonna use data. So stat, and there will be standard deviation is let me see 1.5. 1.5. So enter. What's the sample mean? 3.9. Enter. What's the sample size? 952. Enter. What's the C level? 0.90. You don't have a 0, but you know whatever. Calculate. There you go. That's it. It's that simple, right? So the lower bound, the lower end of the estimation is 3.82, and the upper end is 3.98. That's that. Now, I want to use this opportunity to use the web calculator to show you, that we can get somewhat of the same answer. Web calculators are a lot more powerful. So this is from the email that I sent you. So that first one right here, C confidence. It's basically the same. Z and T, they do both of them. So digit, how many decimal places do we want? I'm just gonna say 3. All right. And what's the confidence interval? It's 0. Let me see. Well, actually, let's do 2 digit since I have 2 digit here. What's the confidence interval? What's the 0.90, right? So 0.90. What's the population standard deviation? This is the key. If you leave it blank, then you're going to be using T confidence interval. But now we're going to use Z since we know it. So 1.5 is the population standard deviation. Now look at these two here. Enter raw data and summarized data. Summarized data is is the sample statistics. It's basically what we have right now. They give you the mean and the standard deviation and all. Average, the mean is 3.9. The sample mean is 3.9. We don't know this one, so let's ignore that. The sample standard deviation, we don't need it. Why? Because we have 1.5, so we don't need it. What's the sample size? 952. Calculate. Let's see. So 3.52 to 3.98. Isn't that the same thing as what we have here? So now some people prefer the calculator, right? Some people prefer using a web calculator. I don't care. And in our case, you can use whatever you want. My advice is to know how to use both, so you can check the answer, you can cross-reference. Now, I want to go to a different example that would give you some sort of so I'm gonna make an example right here. So let's just say, right, we have right here. So let's just say we have consider example. Let's say we have a bunch of raw data. So given the raw data from a survey of income, and the data would be, let's say it's 25,000, okay, 15,000. Let's say it's 30. Well, actually, you know what? Yeah, just do 25. Just say that's 25,000. You know what? Let's make it easy. How about this? Survey of age, 25 years old. So they just go randomly. Let's just ask people from the college that we're in, right? Just randomly pick people and ask them 25, 20, 20. Let's just say 17, 18, 20. So I'm just making up some information. I want to do 10 in a row. So I'm just making it up. Like this. So given the raw data from a survey of age, with let's say that assuming, so let's say the population standard deviation is, let's just say 2.5. Find the confidence interval with, let's just say 95% confidence interval for the population mean. Right. So find the confidence interval for the age, because there are 30 people that you survey. It doesn't represent every single body. It's not the same thing, right, as everyone in the college, right? You might have, for us, we have like 1,400 students, right? So the question is, can you use that information to predict, or not predict, but to estimate, right, a range for the population mean? So this is the part where I say go to stat, right, test, Z. Now we're going to use Z interval. Use Z interval because we know, because we have a sample size of 30. We have 30 sample size, so that meet the criterion, and we know the population standard deviation. Okay, so the problem is this: for input, you have to select data, because I'm giving you raw data this time. So go to data, click enter, and then you have to actually put in information here. You see this? So we are going to, so let me just put in the standard deviation is 2.5, right? And they're like, what's L1? This is when you have to go back and change things. So his second mode, we have to input data, input the raw data into the calculator, into ATI immediately. Right? How do we do that? It's the same thing as when you do the other one sample statistic before. Press stat, then hit enter, press enter to select edit, right? And then you see this right here. Let me clear this off. We're going to use the same thing. Like this. So we're going to go ahead and put the numbers into the first row. You can put the second row if you want to. 25, right? 20. I know this is a pain, so gotta type it in. Like this. So now second quit. Now let's go back. Stat, Z interval, right? Data. Now L1 is the one we use, right? Now let's say you did not use L1. What do we do? Just clear this. Hit second and just is it L2, L3, L4? You do L2 if you want to, right? But for in our case, it's L1. Right? This frequency list, just put one. Frequency list is just sometimes you might have multiple inputs. Say it's like a bunch of 20s. You can arrange that that 20 will repeat itself like 10 times, but we're not going to worry about it right now. So C level is 0.95, so let's put 0.95, calculate. So our confidence level, right, is 24.739 to 26.528. That's it. You let the calculator do the work for you. Now, it turns out you can do the same thing. Let me see if I can copy this and put into the website I sent you. Um, so I'm gonna do 2 digits again. Was it 2 digits or 3 digits? Let's do 3 digits. Comes in equals 0.95. What's the population standard deviation? 2.5. 2.5. So now this time it's not summarized data. You have to go to raw data. So you're going to include the outliers because this is a homework problem. So you're going to have to use all of them. In real life, that's when you may have to exclude outliers. Calculate. Got it. Nice, right? The 24.739. So it's a one difference, 26.5 to 2A. It's a little bit of difference. It's not enough to make it wrong. But so that is the mean confidence. Very nice, right? Now, if you actually scroll down, look at this. Standard deviation confidence interval. So this guy also do it for the standard deviation. That's what makes this so powerful. This website here. It's a lot more powerful than the calculator, right? But here's the thing: use multiple different tools. The idea of this class is you need to learn how to get to the result and interpret the result. The way to get to the result is open because it's man for stat. You have just for my class, right? Not just I on the PowerPoint lecture I gave you, and also on the some other videos. Not only calculator, right? Not only TI-83. We use R, we use Excel. There's so many different ways to get to the answer, and that's just 3 ways. We still have Python, we have SAS, we have a whole bunch of different tools to get to the answer. So I don't care how you get to it. The question is, do you understand the result? Can you explain to people what does this mean? This means that if you repeat this sampling, we sample 100 times, 95 times of the 100, you will get a sample mean in between those two values based on our method. So that should do it for this session right here. And confidence interval is not difficult. It's just the computation is not difficult if you get a calculator. You just got to understand what it means. But you should find the session a lot easier than all those compound combination stuff that we had before. So that's the end of the lesson. Thank you for your attention.